previous lecture, we have already seen overview of cloud computing. We understood that data center is the place where storage and computing servers are housed and networked to provide various kind of services to the user. So cloud computing is a big shift from the traditional way companies and industries think about IT resources. It is favorable in terms of cost as it eliminates capital expenditure completely. It provides high speed. A vast amount of resources can be provisioned in minutes. It is elastic as it has ability to scale up and down dynamically on demand. It saves time and requires little or no management from the user side. So today in this lecture, we'll understand evolution of cloud computing. We'll look at the trends in computing that led to evolution of cloud computing. Centralized computing, parallel computing, distributed computing, cluster computing, grid computing, utility computing. And finally, we will see that how cloud computing is and is not similar to these computing trends. So cloud computing overlaps with distributed, centralized and parallel computing. So let us look at these terms first. Centralized computing. In centralized computing, computer resources are centralized in one physical system. Resources such as processors, memory, and storage are fully shared and tightly coupled within one integrated operating system. That is, one operating system controls all these resources. Many data centers and mainframes are centralized systems, but they are used in parallel, distributed, and cloud computing applications. Next, parallel computing. The field of parallel computing overlaps with distributed computing to a great extent. In parallel computing, processors are either tightly coupled with a centralized shared memory or they are loosely coupled with distributed memory. Interprocessor communication is accomplished through shared memory or via message passing. So that is in parallel computing, there can be many processors which are tightly coupled as they have a shared memory, and the interprocessor communication takes place through the shared memory. Or we can have many loosely coupled processors, each having their own memory, and for interprocessor communication, they pass message to each other. That is, it is accomplished through message passing. Distributed computing. So clouds are essentially large distributed computing facilities that make available their service to the third party on demand. So let us see what is distributed computing. It is actually a field of computer science that studies distributed systems. In a distributed systems, components are located on different networked computers. Information exchange in such a distributed system is accomplished through message passing. Parallel computing can be considered as a subset of distributed computing. Cluster computing. Let us first try to understand what is a cluster. So cluster refers to many computers which are connected closely on a network, usually LAN, to perform like a single entity. So clusters are actually low-cost alternative to the use of mainframe and supercomputers. So when the mainframes and supercomputers evolved, they were extremely costly. So an alternative to that was cluster computing. Instead of purchasing a supercomputer or a mainframe, what industries or firms did, they purchased many commodity computers. Commodity computers are those computers which can be bought from the market and are low cost devices. So they purchased these commodity computers and networked them so that they can work like a single entity to give performance equivalent to that of a mainframe or supercomputer. Commodity machines could be connected by a high bandwidth network and controlled by a specific software tool that manages them as a single system. Built by machines, they were cheaper than mainframes and made high performance computing available to a large number of groups. Finally, clusters are easy to extend if more power is required. By adding few more commodity computers, the processing required amount of processing power can be obtained from a cluster. Next was grid computing. So first let us try to understand why grids evolved. So cluster had become quite a common resource, but the problem was either they were underutilized or the demand for the computational power was beyond the capability of a single cluster. So, and then by this time, the networking and internet had evolved. So it was possible to have long distance, high bandwidth connectivity between two systems which were geographically not co-located. This gave rise to grid computing. So let us look at the definition of grid computing. Grid computing is combination of resources from multiple administrative domains to reach a common target. So multiple administrative domain here refers to the domains which are under different service providers. So in a grid computing, computers do not have to be in the same physical location, unlike cluster computing where they have to be in the same physical location, and here the computers operate independently. Each computer is a distinct computer with a different operating system and hardware. Different from a large cluster, its scale was nationwide or even worldwide. Next, utility computing. Let us see what it is and what it is not. So utility computing is not a new paradigm of computing infrastructure. In fact, it is a business model in which computing resources such as storage, computation power are packaged as metered service similar to a physical public utility. Let us understand this with an example. Electricity is a physical public utility. The amount of electricity we consume is metered and we are charged based on that consumption. So similarly, in utility computing, the amount of computing resources that we use will be metered and users will have to pay as per that, as per the consumption. So utility computing is typically implemented using other computing infrastructure, example grids, with additional accounting for monitoring service. So what happens in utility computing is user assigns a utility value to their job. Shared systems are viewed as a marketplace. So where users will now compete for the resources based on the utility value they have assigned to the job. In this, shared systems are not geographically co-located. Cloud computing. So we can now understand that definition of cloud computing overlaps with the technologies such as grid, utility, and distributed computing in general. Let us look at them one by one. So cluster computing focused on a traditional non-service application, whereas cloud computing focuses on providing services to the users. Cloud computing has indeed evolved out of grid computing. So similar to cloud computing, grid computing enables aggregation of distributed resources and transparently access to them. However, due to shift in focus from an infrastructure that delivers storage and computing resources, as in the case of grid, to the one that is economy based, aiming to deliver more abstract resources and servers, which is the case in cloud computing. Finally, cloud computing is a broader concept than utility computing. Cloud computing lies at a large scale side. This is the reference. Thank you.